Okay, in this video I want to review tangent lines, normal lines, and lead that into a review of linearization, kind of a simple review. Finding the equation of the tangent line at x equals 1. Well, let me bring this down here, I'll solve them. Every tangent line needs two things. It needs a point and it needs a slope. So obviously I'm going to need the derivative. I'll write that up here. F prime of x is 8x minus 7. Okay, so let's get the slope first. Since we just found the derivative, we plug in 1. We get, f prime of 1 is 8 minus 7, so the slope is 1. The point, well, I know x is 1. To get the y value, I simply plug that into the original function, f of 1. So 4 minus 7 is negative 3, plus 2 is negative 1. So my tangent line, slope, x minus the x-coordinate plus the y-coordinate. There is my tangent line. Now, the next question says, use the tangent line to estimate the value of f of 1.01. Now, f of 1 was easy enough to plug in, right? 4 minus 7 plus 2, but 1.01 squared would be kind of a pain. So I just want to draw a quick sketch of what we're attempting to do here. Let me put this just over here. Let's say we have a curve, right? And we have a tangent line. Something like that. Okay. What we're attempting to do is use the tangent line to estimate values near the point of tangency. We've created this tangent line at x equals 1 because that was an easy spot to do it. We plugged in 1 to the function. We had an easy time getting a y value. We plugged 1 into the derivative. We had an easy time getting the slope's value. But plugging in 1.01 is more difficult, and this is a nice way to estimate things without actually having to plug in 1.01. Now, if you're thinking, well, why couldn't I use my calculator? Well, certainly nowadays you could, but before calculators were around, before they were so easily accessible, this was a great way to estimate values by using the tangent line. So all this means is let's plug 1.01 in for x. So slope 1.01 minus 1 minus 1, like that. So this becomes 1 times 0.01 minus 1. So this becomes 0.01 minus 1, which is 0.99. Now I would urge you to go to your calculator and actually type this in and see how close we got. And again, this works well because the tangent line was at 1 and we're estimating for 1.01. We would lose accuracy as we moved away from the point of tangency. If we started going up here, the tangent line and the curve aren't by each other, so the tangent line is not going to be a good approximation. But for values right around the point of tangency, this works really well. Okay, let's do the normal line. So remember, a normal line also needs a point and a slope, but the normal line is perpendicular to the curve. So if I plug 2 in, let's do this first. I have 4 times 4, so 16 minus 14 plus 2, so 4. The slope, I plug 2 in to the derivative, so 16 minus 7 is 9. So this is the tangent line slope, so the normal line, let me just write an arrow here, would be negative 1/9. It's the opposite reciprocal because it is perpendicular to the curve. So negative 1/9, x minus the x-coordinate plus the y-coordinate, like that, and we are done. Let's do a couple more quick linearization problems. All right, I'm going to approximate the value of the square root of 50. Now, of course, I don't know the exact square root of 50, but what you, I hope, are thinking is, boy, it seems like it would be close to 7 because we know what the square root of 49 is. Well, that's exactly the point. I do know what the square root of 49 is. So what I'm going to do is I'm going to create a tangent line for the square root of x at x equals 49. And the only reason I'm choosing that is because I know that one already. I know what the square root of 49 is. So when I go to make my tangent line, and I say, well, I need a point and a slope, I know that 49 and 7 are on my original curve. Okay. Now the slope, hopefully you remember the derivative of square root of x. Let me just write it right here. F prime is 1 over 2 square roots of x. Okay, we use power rule, rewrite it as x to the 1/2. So if I plug 49 into this, I have 1 over 14. Okay, so 1/14. So my tangent line looks like that. Now, again, what we're doing here, if you think about the square root function, is we created a tangent line, and we're using that tangent line to estimate other values close to the line. If I said, hey, let's do the square root of 26, I obviously would not be picking 49 as my value to create the tangent line at. I'd be picking 25. But for 50, we're really close. Now, one of the things that trips people up is they'll say, well, how would I have said x equals 49? Why not 7? Well, remember, the function is the square root that we're trying to linearize. Ignore the 50 for a second. Just say, what function am I trying to find a tangent line of? And then you pick the value that you plug into that function, right, that would be close to 50. Because here x is 50, we wanted it to be 49 because then we could easily find the y value. So now we actually plug this in. This is our x value. So 1/14 is 50 minus 49 plus 7. Now sometimes people say, well, shouldn't I be plugging in the square root of 50 since that's what I'm trying to find? No, the square root of x is the function, and the x we used was 50. So we just substitute in. We said, well, x is 50, so I substitute that into the line. So this comes out to be 1/14 plus 7. And if you want a, you want a common denominator, you could rewrite this as 1/14 plus 98/14. This comes out to be 99/14. Now again, I would urge you to actually go in, type in the square root of 50, type in 99/14, and see how close they are to one another. They're not exact, but they're awfully close. Okay, let's do one more. The cube root of 63. Okay, so the function we're trying to linearize here is the cube root function. And my x that we're looking for, of course, is 63, but the x we're going to pick that would be easy is 64. The reason we're picking that is because the cube root of 64 is 4. So the point, 64 comma 4. Slope, well, we need the derivative. So x to the 1/3 would have a derivative of 1/3 x to the negative 2/3, or 1 over 3 x to the 2/3, or 1 over 3 times the cube root of x squared. The other way you could think about this is that it's the cube root of x then squared. So when I plug in 64, the cube root of 64 is 4. 4 squared is 16. 3 times 16 is 48. So this becomes 1 over 48. So my tangent line is 1/48 x minus the x coordinate plus the y coordinate. There's my tangent line. So now I substitute this x value that I actually wanted to estimate in, because the tangent line should be really close to the curve. So 1/48 of 63 minus 64 plus 4. So I have negative 1/48 plus 4. Okay, and if you want to think about a common denominator here, 4 times 48 would be 192. So you could think about like negative 1/48 plus 192/48. You would get 191 over 48. And again, I would type that in the cube root of 63. I would urge you to do that real quick and see how close we got.